restart the stream and figure out what we did.
Okay.
So the diff in the grammar is oh, Lone Star expression. Wasn't this something we found in the yeah, in the poster?
Oh,
Star expressions somewhere.
There was star expression, and oh right, there was a star. Hang on.
And there's star expression, but you cannot just
do it
use
by
one.
itself.
Right. Because it creates a tuple, right?
I don't remember what happens, but I know it's not supposed to be.
So you can do...
That's what it is. The grammar will accept something that the Python compiler will not.
Exactly. So you can have something like this list, and then you can have this.
Yes, we want the grammar to throw an exception,
which is
to make an error.
Oh, this is fine, but you cannot have just one. If you have just one, you need a comma after it. And currently the grammar allows that without the comma. And we want to oh, it allows that without the comma because there's a can't use start expression here in a later step of the parsing, where if you have a star expression somewhere it shouldn't be, it'll just raise a syntax error. But we want this to be visible in the grammar itself. So we made some changes, and what's the best way to look at these? So we made some changes in star expressions, which is the rule responsible for this. And that says it can be star expression and then one or more comma star expression followed by a comma, or it can be a star expression followed by a comma, but you cannot have a star expression by itself. So the difference here was previously there was star expression all by itself, and now I just want expression in here. And there's an extra invalid rule. If you're tuning in for the first time, the invalid rules are ignored when parsing normally, and whenever you get an error, these are included and the source code is reparsed, and these will always raise an error. So this is can't use star expression here, and the question mark is probably a bit of debug output, so that this error message isn't the same as the one here. So when we get the error, we know which one we got, and hopefully that'll be found in review before sending the pull request. And this looks fine. the tests, but if I also run Python here, I get this syntax error from the grammar itself, which is great. And I hope yeah, this is still valid, this is still valid, and so on. Right, so this part looks good. The thing is, we also ran into this in del targets.
Oh, that's right, del targets.
So you can do del and some kind of stars. What can you do with the del statement? And this is time for the poster again. So del targets, and what do del targets look like? Target primary, del target atom. Oh, are there any star expressions here? Why we have issues with del targets? How did we get here?
Oh, because we're doing def. Wasn't def the opposite of del? Or del was the opposite?
No, that was just del. So let's look.
I don't remember how we got there. Yeah.
So del targets. Previously, this was this a blah 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 equals comma separated list of del targets and an optional comma. I don't know how we got here. Let me remove this and maybe then rerun the tests. Okay, so these are the tests we need to run. So problems here. X equals a star. Can't use star expression here. So the problem here is the question mark that we added on purpose, so that's fine. And this is cannot delete start. Ah, right. Because somehow we got rid of this error message and instead we're getting invalid syntax. So if I run normal Python, like my system 315, and I do this, I get cannot delete start. And we somehow got rid of the message. That's probably coming from here. Raise syntax error invalid. Target. So from our change to star expressions, we got to the del statement. So how did we get there? So del target can be a t primary dot name. So this is attribute access t primary, and then something in brackets, or del t atom. Del t atom will be a name, or del target, or del targets, and that just goes back here. What did we change by our expression? Oh, maybe that was in the del statement. Ah, right, there's invalid del statement, and that has star expressions here. Maybe we just need to add del star expression as invalid. Nope. There's star expression again. Does that? I guess I'm in the same place as last week right now, ain't I? Were you able to follow that?
More or less. I don't remember how we got there, but yeah. We may have to look at the video again.
Okay, so how we get there, so there's the del statement, and
yeah,
you cannot delete everything. You can only delete deletion targets, which are attributes, things in like item accesses and square brackets. You cannot delete a function call.
Oh, I see.
Doesn't really make sense. So the syntax has these deletion targets,
right,
which are defined properly as the syntax for whatever you can delete, and then if that fails to parse, the entire source code will be reparsed with these invalid rules enabled, and that's what gives you the syntax error. So we have invalid del statement, and that has del star expressions. And star expressions is basically the expression statement you can write. So this is star expressions. The function call, that's also star expressions. So anything that isn't a special kind of statement like if or continue or things like that will be these star expressions. That's the expression statement, right? And there's this special function here which looks at the type of these star expressions and gives it a human readable name and gives you the syntax error, cannot delete, and whatever it was after the del. Right, so it can be literal, or it can be, oh, you can do tuples, you cannot delete dict literals, whatever, cannot delete arbitrary expression, and so on. Right?
Okay. Yeah.
And if you put in a start expression, then the normal Python will tell you cannot delete start, because this is, in the current Python grammar, syntactically a star expressions. Right, but we're trying to not make it one. So when we change the syntax so that this is no longer a valid statement on the syntax level, this stopped working and started giving generic invalid syntax error.
Errors, right.
Does that make sense?
Yes. So the question is, how do we make it?
I guess the answer is we put in a star expression here. And oh, maybe I didn't regenerate the parser, and that was the problem. Takes a while to compile. And there we go. That says can't use start expression here, which is better. Maybe we need to put this before and add this look ahead. So if we par del star expression, oh, and I guess we also need to make sure it's a star expression with this star. Does that make sense?
Yeah, so far. Yeah.
Ah! Yes! Great. Great, great, great. So now you can do del avcdf. Oh, no, abcde. Oh, it still cannot delete start. Because this is now valid star expressions. Let me right. So with the normal Python it's the same thing, so we probably don't need this look ahead. Oh, good. Okay. Aha, that was nice. Let's see what else broke. Right, let me remove this debug thingy. Okay, what else broke? I didn't run the regeneration. So every time the grammar changes, I need to run a special build step. That's not run by default. Oh. Okay, we broke something horribly. As it happens when you change the syntax, right?
Yeah, exactly. Messing with the fabric of the universe.
So this says can't use start expression here. Let me do one more thing. Let me go to this code gen. Oh, this one has an exclamation mark. Which we also added, so I guess the question mark wasn't necessary. Okay, so what happens here? Can't use start expression here, and that is coming from our invalid lone star expression rule. Right? Cannot use start expression here. Haha, this is interesting. So this is attempting to parse this as a star expression. Why? And I guess now it would be nice to somehow turn on debugging in the parser. I don't know how to do that though. There's some parser docs. When Python is compiled in debug mode, it is possible to activate a very verbose mode in the generated parser. Yes, yes, I want that. Add the D flag when executing Python. Alright. So Python-D, and then we want to execute this return I for I in range n. Ooh, alright. That's a lot of information, so.
Wow.
Okay, that's probably
Wow.
parsing all of the standard library, isn't it?
I don't know.
So we can't just start at the beginning. So, wait, if I just run pass. So it'll say this succeeded for statements, simple statements, pass statement, right? It succeeded with the pass. Oh, and it looks like It looks like this is only for the pass. Okay, so the simplest Python program is parsed like this. So it's looking for statements, it's not finding a def or async or whatever. Goes to simple statements, tries all the simple statements, including star expressions. Whoa, that's a lot. And it goes to def and for. Was that compound statements? Oh, compound statements first. And simple statements. And compound statements somehow. And simple statements again. How does this work? Oh, it went to simple statements, then it found the pass. So simple statements succeeded. And now it's looking for more. So it found a statement. And it didn't find anything after it. Right. So there's pass statement. And I guess it consumed the new line after it, and now it's looking for another statement, and it didn't find that. Alright, so that succeeded. Okay, yeah, I think I understand this a bit more now. So let's try with the original. So return blah 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 for I in range. That's a lot more. Will it stay in my output buffer? Probably not. No. So I need to somehow redirect it to file. Okay, that didn't work. This needs to go the other way. Don't we love Unix? Anyway, here's the parse log. Do you want to open this file using my graphical editor? Sure. That's snappy. Okay, so we're looking for statements. It's not a compound statement, it's looking for simple statements. And there it's not any kind of expression. We're looking for... Wait, shouldn't this be for? Oh no, return, that's a simple statement. So it's not expressions. Return statement. Okay, so return star expressions. So it's looking for a star expression, which might be star bitwise or. fails, right? So it's looking for an expression which is lots of stuff, and it finds name, and name is because we have this return I, right? So this name succeeded, and I think these are token ranges. So return is number 0 and this I is number 1. So this says token number 1 succeeded as a name. Does that make sense?
Yeah, I think so.
So what do we do then? We try the star here. And term succeeded, so factor succeeded, power succeeded,
Wow.
name succeeded, this one, term asterisk factor succeeded. Right, so that's 1 to 4. 1, 2, 3. I don't know why the 4 is there. That's interesting. Anyway, term succeeded, a bunch of other stuff succeeded as well. And then return star expressions succeeded. Right. And that succeeded, but then it's looking for a new line. So even though the return statement succeeded, a simple statement loop succeeded, then it's looking for a new line, and that fails, which means this is not a statement. And what happens then? Statement plus failed, and this is now trying to parse again. Let's see what succeeded now. Oh, this is the same thing. Vector succeeded, name succeeded, stuff succeeds. But invalid if expression failed. Right, so the rest of this giant file is now going through all the invalid rules. So it's not an invalid if expression. What's next? Invalid lone star expression succeeded. Right, because we have... Wait, why? So it was looking for an invalid lone star expression here. Inside invalid legacy expression. Let's see what invalid legacy expression is. So that's name star expressions. Right. Okay, so I know what's going on now. Did I lose you?
No, I'm just wondering, is this some old Python 2.0
Exactly.
thing?
Yes.
I see.
So in Python 2.0 you could write print 1, 2, 3. So print and then expression. So there's this extra rule that says there's a name and we're ignoring parentheses. Oops, sorry. We're ignoring parentheses now because if there is a parentheses you probably want the new form. And then star expressions, right? And then there's the spy pgen check legacy statement, which I'm really curious about now. Oh, exec worked the same way, so it's generic. So it's both for print and exec. So this says missing parentheses and call to print or exec. Did you mean that with parentheses, right? And our problem is that when we do this return I times I for I in range n, is that this gets parsed as an expression, and this I gets parsed as the name, and then this gets parsed as star expressions, and that raises the syntax error. You can't use star expression here, right? So I guess the fix would be here to add a negative look ahead to this one. And now for the return thing we get invalid syntax, which hopefully is the same as normal Python. Yes. Whoa. And wow. What? Which test found that? Let me run the tests again. Or maybe I have that in the other one. Oh, doc tests. Here. Verify that parentheses are required in a statement. Yeah, so this raises invalid syntax. Okay. So let's rerun those tests again. And we're good. And I guess what I want to do now is verify that this is no longer necessary. So I will assert 0 or make this unreachable somehow and rerun tests. Let's see if that's correct. I've added the exclamation mark here, so anything that checks the error message should already error out.
exclamation. I see. Okay.
What's this? Visit expression implementation. Oh, we're good. So, okay, so we're good.
Yes.
Tests succeeded. Let's look at the difference that we made. So del targets, oh, this is the difference from the previous commit. So the difference is in star expressions, we disallow star expression by itself and replace by a star expression. For context, let me put in more context. So for context, star expression is either star and a different kind of expression, or an expression itself. And we instead have invalid lone star expression. So an invalid legacy expression, that was the print or exec, we disallow stars after the print and exec, just so we don't fall into this case. Invalid lone star expression now is the missing case here, which raises a nice syntax error. And for invalid del statement, we add in the missing case here. Right? Yeah, and that should still work. The rest of the change is this giant diff in parser.c, which is generated because everything got renumbered. origin.age. I don't think we want this change, do we? Syntax or invalid target. Let me put this back in. That was probably from the previous commit. Oh, this is the one that says cannot delete blah blah blah. Oh, and this has returns, race syntax or known location here, and then another return after this return, so this doesn't do anything. But it's I probably don't want to put that in a pull request since it's an unrelated cleanup. And then I add a comment here, just in case we do get here, we get the error message, can't use star expression here. So one more run of the tests just to make sure this doesn't break anything, and I think we can send it as a pull request. So questions for you then. Was this interesting? Should we do more of that on this stream and get better at it? Or did you fall asleep already? I guess you did.
Oh, sorry. I just went went to grab a drink.
Oh, that's fine. So was this an interesting exercise? Should we get better at this kind of thing on this stream?
I think so. We learned how to turn on the debugger.
Yeah, -D. I guess if you do python --help, it'll tell you -D. Right, it's right there. How could I miss it? Oh, and you can do Python debug. No. How does Python debug work? No, I need to.
It says it only works on debug builds.
Oh, right, debug builds only. Yeah, there we go.
Wow.
Okay, this is probably compiling all of the REPL. Oh, and it's also debugging the REPL, not only the parser. Nice, nice. Okay. That's fun. Alright, so the whole test suite is almost done. 6 more tests, which probably are not parser related. So how do we file this issue? We have like there's this rewording issue which continues after 2 more. And should we link this to this align the grammar documentation with Python's actual grammar?
Yeah, I think so.
Probably, but it does need to be a new issue, right? Create sub-issue.
Yeah.
Okay. Create sub-issue. No, nothing here. Let me do a blank issue here. Do we have more of those? Should we make a big issue for aligning the grammar, like removing special cases from the speech and .h?
I don't think we did.
Yeah, we don't have one, but I don't know if we will do more of these. So let's see, there's this trace syntax error, and let's see which ones. So there's cannot assign to and cannot delete. Or invalid targets. And these, I think, are raised from the grammar itself. Oh no, right, I should be looking at this codegen. This was a codegen. So pycompiler error. So break, continue, and return cannot appear in an except star block. And codegen is probably the right place to do this, assuming return and break and continue are also handled here in general. Type parameters. Non-default type parameter follows default type parameter. Oh. That would be nice to put in the grammar. But I can see why people put it here. A bit sloppy, but much easier. So, you know how this parameters grammar is very complicated.
Yeah. Yeah, I do.
So for type parameters, this just has one thing repeating over and over. But in reality, it has some of the same limitations as the parameters. Looks like non-default type parameters cannot follow default type parameters. And that's just handled outside the grammar. By this scene default rule. Might want to look into the history here. Let me put it on my to-do list. I might want to look into the history of how this code got into the code base and the discussions around that. Might be interesting to pull that into the grammar. What's next? Return outside function, return with value in async generator. These are probably best at this level, not grammar, because we need to have different variations of all kinds of statements depending on if we are in a function or not. Break outside loop, continue not properly in loop. Same thing here. What's the difference between outside and not properly in? These. These look the same. Huh. Interesting. Default accept must be last. Oh. Right, so this is also not something present in the grammar, but if you have except blocks, the except without the exception must be the last one. That's probably something we could put in the grammar itself.
Yeah.
Validate lazy imports. Lazy imports are only allowed in module scope. So this is similar to the restrictions on return. Cannot lazy import star. Okay, that's like for the import statement. Cannot do lazy all of this and go to the star here, which is probably probably better handled here as a note. Can add a note to this diagram or something. Now, too many expressions in a start unpacking assignments. What the? Whoa, nice. If I is bigger than 2 to the 8th power, so okay, that's like several hundred. So if you have a comma repeated 300 times, and then you put equals range 300,
Yeah.
this would be invalid? No, that's fine.
What if it was range 299? In other words, does that work because the number of A's equals the range?
Well, that works. That just
it
assigns each element of range to this variable in turn. So,
I see. Okay.
Okay, so that's not it. So what does this do? Oh, it's about start expression. And this isn't valid. This should throw the multiple start expression in assignment. Right? Well, that's this. And this says if this is start and we haven't seen a star yet. Ah, I see. So this has too many expressions and start attacking statement. That makes sense. You have a lot of variables and then you follow up with a star. So apparently in CPython you can only have 256 of these.
Okay.
That's an interesting edge case somebody thought about.
Wow.
And this probably shouldn't be in the grammar, but this one should. So if you look at the grammar itself, so this would be an assignment statement, and this says you can assign to this target. Oh, that's probably the single target. No, target primary. And target primary then can be an atom. No, that's not it. Where? No, maybe it's this target. Star. Non-star target. Where does the star come in? Oh, you can have multiple targets, and that's where the star comes in. Right. Right. So here you can have multiple targets, but only one of them can have a star in front of it. So that's also something that we could move to the grammar itself. Now this is keyword argument repeated, right? So if you have keyword arguments or maybe even parameters, you cannot repeat a keyword argument. That's probably best handled at this level. Now then you have yield outside function, yield from outside function, the cases we solved right now, multiple assignments to name in pattern, right, so this is for the match statement. So if you're matching, you cannot repeat the names that you assign to. Went through this. And yeah, name capture makes remaining patterns unreachable. Or wildcard. That's probably not worth putting in the grammar itself. Like this pattern capture and the wildcard effectively need to be last because they match anything. Might be interesting thing to try and put in the grammar itself. Attribute name repeated class pattern. Repeats are probably best handled here. Now what's here? Code pattern class. keyword attributes or keyword patterns length mismatch in class pattern. So this shouldn't happen. And then there's too many subpatterns in class pattern. That's not problem. That also shouldn't happen. Can't use null keys in match mapping. Oh, this is probably for the case where somebody created an AST by hand.
Oh.
Mapping pattern checks duplicate key. Mapping pattern keys by only match literals and attribute lookups. Okay. Mismatch. Many stuff. Alternative patterns by different names. All pattern matching. Multiple start names and sequence patterns. Right, so this is also something that could be in the grammar. Patterns may only match literals and attribute lookups. Don't know where this would come from. And that's it. So there's a few of these compile errors that we could move to the grammar. It's probably not worth it to open like an umbrella issue for them. So I'll make this one only about the thing we fixed, and I just forgot what that was. Disallow yield star disallow long start expression at the grammar level. So this would be it. This or yield, and of course you need to have yield inside a function.
Do we refer to the bug in here?
Yeah. So this is basically what I'll write in the issue.
Okay. I'm going to make some tea while you type this.
Yeah, go ahead. How do we refresh? refer to this in the docs. The rule called legacy something. Is that it? Yeah, I think so. Oh no. Oh yeah, that did give the new invalid rule, didn't it? So let's put all of the statements in here. So let's look at the poster and see where star expression is used in a loop, or maybe it would be better to look in the grammar and look where star expressions are used. So they can be used as a simple statement, so that's this one. They're used in annotated RHS. Right, so that would be x equals this, right? They're used in the return statement, they're used in the for statement, so you cannot have for something in this, but you cannot have, you can have this, yes.
Oh, okay.
Fun, okay. Async for, obviously, it's the same thing. Yield we have here. And is that it? Oh, I already checked return. So that's my commit message, and I'll just put that in the bug report. Where's my bug report? Here. Create sub issue. Like issue. Can you hear that?
No?
Good.
Is there some noise out there in the background?
Yes, there's a public announcement playing.
No, can't hear anything at all.
Good. Well, let's put a link here. So documentation. Is it documentation? Probably not. You can see I don't usually file bugs for this kind of internal parser.
Yeah, that looks good.
And
Interpreter, yeah.
and assign to myself so somebody doesn't take it, hopefully.
Should you put codegen in ticks? Backticks in the comment?
Oh no.
No.
I don't think anything is really named that in the source.
No, okay.
There's codegen.c. Code generation, I think, is just a normal word in this case.
Sure, okay.
Project docs issues. Oh, and I put it in the wrong a sub issue in the wrong issue. So this should be here. Can I change that? Change or remove.
Oh,
parent.
change parent. There you go.
There we go. Okay, so we got an issue number, so we can do a blurb. So this is not really a user visible change, hopefully, so we will not make a blurb and just push it. Oh, I need to punch it. Or this is my git alias for git push force-with-lease.
Oh, force-with-lease. Oh, okay.
So I don't know if you know about that, but there's git push force.
Yes.
Which takes my local branch and overwrites the destination with it. Force-with-lease is a little safer. It checks that whatever's on the GitHub side matches what I have locally. Right, so I have a mirror branch for whatever was on GitHub, and force-with-lease will check that nobody pushed to the GitHub branch, because I wouldn't know about that, and if I just did git push force, I would override that. So I don't use git push force. I have an alias for this weird new thing, so in case this fails, I always know something. I'm overriding work that I don't know about.
Oh, so basically you do GitHub force-with-lease and then the branch name.
So the after this is the same as git push.
Oh,
so
I see. Okay. Okay.
My repo, and this is the branch. In this case, it's my repo, so usually people don't push there, but sometimes it happens because when you open a pull request on GitHub, I don't know if it'll be on the closed one. So there's this maintainers are allowed to edit this pull request, which means they can push to my branch. Right?
see.
So, for example, if I have a typo or somebody pushes this updates branch on my pull request, that will change my branch.
Right.
And then if I did git push force, I would override that, which I don't want. I also don't want git push force on a branch that has a pull request open, but on other projects I might want to do that. So anyway, I recommend instead of force doing force with lease. If you have an alias for force, you might want to change it to this.
Right. Okay. That minimizes merge collisions.
It avoids overwriting work that you're not
other people's stuff
that you didn't want to overwrite. So now pull request. And part of this is just this text. No. This text. This is in the commit itself. And I need the issue number. And I probably want to mark it as draft for now.
Okay. Yeah.
Alright, that was fun. Did you find it fun?
I did. Absolutely. Yeah, it was fascinating. It was, you know, I won't pretend to have understood everything, but yes, I learned a lot for sure. And
Well,
I hope my notes
if you
help.
want to do it again, there's a bunch more.
Yeah, actually.
Yeah. Is this better than rewriting documentation?
Yeah.
Alright.
Yeah.
Yeah, so in case you want to try this at home, first of all, I have no idea if the parser maintainers want this change. So I'll open a discussion about that.
I see. Sure.
Whenever I get around to it.
Who are the parser maintainers?
Oh, Pablo?
Oh, those guys. Okay, of course.
Yeah. Well, these are the ones Guido mentioned, right?
Right.
Yeah.
I don't think I know the other two.
They're busy.
Yeah.
Fine. I mean, this, like, the discussion around this will take some time. In the worst case, I'll ask them at the core dev sprint October. No rush on this. But yeah, if we want to do more of this, that's definitely possible, even though it might not go anywhere. But yeah, it's interesting. So the way to do this is to look in codegen.c and search for pycompile error and see what kind of errors can be pushed into the grammar. Right? So here we have break, continue, and return cannot appear in an except star block, which is probably best handled at this level. So the way you would put this in a formal grammar is make copies of every involved rule. Right? So instead of a block, you would have a function block and a class block, and well, this one would be a module block. And then inside of those three variants, you would have instead of statement, you would have three variants of statement. Instead of simple statement, you'd have three variants of simple statement, which would include break and continue, or would not include break and continue. Right. And then in the except star, of course, you would need three variants of compound statement as well, and the only difference with those variants would be all of the blocks would be of the particular kind. And in the except star, this block would be the kind that disallows these three. Right? And that's a lot of duplication.
Yeah.
So this is probably best handled at a level above, like in codegen. Now, there might be other pycompile error calls, not just in codegen, right? So there's a lot of them in codegen, and there's a few in compile.c. Okay. Too many syntactically nested blocks, right? So you cannot have what is this? 21 within a function.
Wow. Okay. Is that something that the parser could find now? I mean, does it keep track of how many blocks you've got?
The parser can, the grammar cannot. So compile.c is part of the parser. But yeah, nesting isn't really a strong point for grammars, like limiting nesting.
Sure, of course.
Yeah, you can't really do that.
And that might also be specific to C Python, I would imagine.
Oh, definitely, yeah. Yeah, so I guess you cannot have def, and then you repeat that. How many was that? 21 times? Oh, we can't do that. Was that more than 21? What kind of block is this? frame block. Maybe they need to be. Oh no, F block is these. Try, accept, finally try. Oh, so it's try blocks. It's not function blocks. It's frame blocks. Okay, so you cannot nest 21 try statements. Probably, or something like that. Anyway, so yeah, this is best handled here, and this is the definition of the function, and that's all the compile errors. There's also by-error raise syntax error, which we might look at, and that is, well, there's the definition for it. What is this? There's emit syntax warning, that's fine. And yeah, raise syntax error is only in compile C where it's used in this compile error. And that is only used in codegen and compile.c, and codegen then provides these macros up top. Where are they? No, not codegen. What provides these macros? Right. Section helpers. Oh, these raise syntax erase error known location. Python raise error known location. Well, anyway, there's these raise syntax error macros. I guess we can go through those as well. Valid target, valid version check, and anywhere these are used outside of the grammar and the generated parser is also a special case. There's this one. Oh, definitions. Okay. There's a special string parser. Hello. Bytes can only contain ASCII literal characters? What?
What can contain ASCII literal characters?
Bytes literals.
Oh.
Seems very.
Now this is the tokenizer. That's like a layer below the parser. So I guess these are fine. Okay, so I guess codegen.c is the only file to look for. Only file in which to look for these compilers. So break, continue, and return. We covered that. The type parameters. We probably won't be able to get that done in 15 minutes. That would be a bunch of work. Now then there's return outside function. That's the same thing as the return continue we had above. Return with value in async generator. That's the same thing. Peter Beer was wanting to change that. Break outside loop, same thing. Continue not properly in loop, it's the same thing. And I wanted to look into what's the difference here. Like, what is return if error? It's defined a bunch of times in several files. So we want the one codegen, right? So return if error. If codegen unwind block stack blah 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 is -1, then it returns error. Okay, so it's this call. So break will unwind the block and jump to exit, while continue will jump to the beginning of the block. Okay. Now that makes sense. I forgot I was in the code generation. So this is the part that walks the parsed AST tree and generates bytecode, hopefully. At this stage we check if breaks and continues are in the proper places. Now try accept. Default accept must be last. This is interesting. So I guess this is if you do try something and then you have a bunch of accepts.
Oh yeah, that one is interesting indeed.
Then it'll tell you default accept must be last, and it would be nice to put this one in the grammar, wouldn't it?
But if you did accept base exception, which is equivalent, this wouldn't be a problem.
Oh, of course.
Yeah.
Oh, I see.
Because we're in the parser, right? If I do base exception equals...
However, this construction doesn't make sense because the value error never gets caught in this construction.
Right, but this is at the parser level, right? I can do...
Yeah, I see, yeah.
Type error, and... yeah, no, it does make sense. Or I can even say base exception is, empty tuple. Right?
Yep, indeed.
That works. Don't try that at home. Or, well, don't try that at work. So, okay, so I want to make a new branch for default except last, and try to move this rule into the grammar, right? So this is in codegen try accept. So what happens if I remove this rule? I'll probably break some tests, right? Let's see how many I break. This in the history here. Oh, test syntax passed. Okay. Is this even tested somewhere? can I just remove this part of the code and nothing will break?
Oh, maybe you can add that command, the python-m test with the UL test groups genx, that whole thing there.
Yeah, I did that.
Maybe you can add that to the little notes that I've got here. Yeah. Or just paste it in the chat.
Oh, this one.
Yeah.
Sure. Whatever test you want to run. Oh, something failed. What was it? Test exceptions. Ah, good. Okay, so it is tested. So we have our failing test. Syntax error not raised. Somewhere in here. Oh, no. Was my editor not working again? There we go. So, oh, this compiles a fragment. Oh, source is try, pass, accept value, error, pass. Why is the traceback not complete though? Okay, so it's this one. What are the arguments here? Oh, the expected offsets. Right, syntax error not raised here. Okay, so off we go to the grammar. And okay, first before that we can test case, and this now passes. So this is my command to regenerate everything and test. And now where do we look in the grammar to disallow this? So this would be the try except exception, right? So somewhere in compound statements there's a try statement with these except things. So the rule is probably called try stmt. We have try block finally, or try block and then except block plus else block finally block. Or we have try block except star block else block finally block. Okay. And except star, being the new thing, does not allow omitting the exception.
Oh.
Which is great, isn't it? So I guess instead of this except block plus, we need a new except blocks. here we have accept blocks. Accept blocks, and that would be of type HDSL accept handler sequence. Who? How do you handle those? What does the plus do? So that can be oh, I guess I need also to look in the accept block, right? To have several versions of that. So there's accept expression colon block, accept expression as name colon block, accept expressions colon block, or accept colon block. And this is the one we want to make special. Right, so I guess we say accept block is either, well, we can keep the invalid handling, and then we can say this can be the accept block with exception type, or it can be the accept block, or well, their accept block, or this thing, right? And now accept block with exception type will be all of these except that one, and bare accept block will be that. Now let's try if that compiles. It does. And it passes except for that one error we had previously, which is great. And since we're out of time, this is a good time to stop and think about this for a week and come back next time.
Awesome.
So this would be,
This is great.
break up accept block. And next time what we'll need to do is make sure that in this sequence of the accept blocks, this one comes last if it's there. So thank you for your attention. As always, I'll push this on GitHub so you can find it if you're determined enough. And see you next week.